Hello. Okay, so today I want to go over the few things that I tripped over last time. And so it was when using the scatter shape node, we had this weird cropping of sometimes the icons, and I really didn't understand why. And so I did some research off camera, and this is more or less something I want to do as a thing I do in my channel. I'm not willing to say format because it would be like quite an overstatement, but like I go live with an ID and try to do stuff, and then come across something difficult or something unexpected or something I don't understand, and I try to dig into it live a little bit, but if I fail too long, I move on the next topic, but I keep a note of this difficulty and revisit it on my free time. And to revisit it, I have different things I do. I can just spend more time alone with the problem. I also ask Claude for help a lot of the time. And once it's done and that I've understood everything, I will ask also the AI to create a little note, a little markdown note that I also synchronize on Notion. This makes, so you will probably see during the live the Notion pages that Claude created for me about those particular problems, and this will help me keep the live a little more focused, and maybe help me if I ever forgot stuff, which I probably will. So the 3 points that have been difficulties last time had been this cropped variant thing. I also wanted to learn how to use the ID layer inside of Copernicus, because it's pretty easy to use ID in SOPs and to do wrangle operations with them. And it's obvious that ID can be used to do similar things inside of Copernicus. And I wanted to explore that. And this brought me to a whole other rabbit hole, because you can't really use ID the same way you do use ID in COPs. You have to... how to put that? Well, I went down to the OpenCL node because of this ID of ID, and this is quite a deep topic, and it doesn't work exactly the same as wrangles in other contexts. So I've just dipped my toes into the water here and learned a few stuff that I will share after that. And finally, the big issue that was really not easy to understand for me was this data window thing with the photo that kept being cropped seemingly for no reason. Now I have a pretty good understanding on what was going on, and I think it's worth talking about. So just a sip of coffee and we'll dive in. It's not that I try to imitate a lot of the coffee YouTubers, but I just needed a, a little espresso before starting. I could have drank anyways. Let's move on. So the cropped variant. So this one, no, I don't need to see that. Yes. So with the shape scatter nodes. So the thing with this node is that it's using, so stems are the items that you are copying, and they can be they can be numerous, or they can be few, and this is controlled here with the stamp number. So the amount of stamps to scatter along both the X and Y axis of the image. So this means a grid actually. Like if you put 2, if you put 1, you will get only 1 stamp. Okay. Okay, this was 11, not 1. So 1 gives you 1 stamp. And 2 gives you 4, because amounts of stamps scattered along both the X and Y axis of the image. So yeah, this is pretty much a 2 by 2 grid. This is also why you have this link stamp option. It allows for uneven grids. And since in this one I'm at a 16 by 9 aspect ratio, I could do 16 horizontal stamps and 9 vertical stamps, but no, because it makes the stamps, it stretches them, so this is not a good idea. Let's keep link stamps. So now we get this grid ID, and this allows to, so Claude told me that it's for calculation under the hood. Each square of the grid is calculated separately, apparently. I'm not really sure about that, I don't know. Anyways, this grid ID is very important because it is the grid that creates the cropping. I'm not sure this is really intended behavior, but if you scatter a lot of stamps and then you move them around with jitter, for instance, sometimes, see, you will hit borders. And you can really tell that these are the grid borders because the alignment is pretty revealing. I mean, this is clearly aligned. Those three are all cut along the same line. So yeah, this is the thing. And what's weird, you could imagine that, okay, the stems are leaving their square and you cannot longer see them. But there is a bleeding mechanism, see? It's just that it doesn't trigger until a certain point, and probably this point has something to do with the stamp being on the other side of the separation, it would seem. Anyways, it's a bit weird, but it's comprehensible. And once you get that, you can avoid it. So, one topic down. Hey. Next, ID. ID. It's been really fun to try OpenCL, the OpenCL node for the first time, and I will show you what I've learned, and it's the very, very basics. So yeah, it's not for you if you already use this node, but if you know how to select things by ID in a wrangle and you tried the OpenCL node without understanding exactly what happens and gave up, which I understand that it's probably a very few amount of people. But anyways, it was my case until this morning. And yeah, so let's just get a bigger a bigger view. Let's remove that. No, let's keep it. So we can see pretty clearly that we have the ID, and it could be a cryptomat, but anyways, it's an ID visualizer like we're used to. And oh, so the first thing I've learned is that, because I tried to do it with a wrangle, because I know wrangles, but when I asked Claude about what's the difference between a COPS wrangle and a SOP wrangle, for instance, he told me that actually wrangles in Copernicus are not the recommended way of doing custom code, because so apparently the wrangles in Copernicus are equivalent to the volume wrangles, because every layer in Copernicus is treated as a volume, which I heard about during Copernicus presentation. You must have too, and it also makes sense, because what are pixels? Pixels are voxels, but with one dimension that is not forgotten, but reduced to a single point. Anyways, pixels are voxels. You could argue that, even if they are not. So it makes sense that the volume wrangles would be the wrangles for Copernicus. But apparently volume wrangles in Copernicus are CPU bound, and they are single-threaded, so they are pretty slow. Hence, their recommendation for using OpenCL that is handled by the GPU. So it's a whole other code node to learn, and I'm at the very beginning, and this is what I've learned so far. So let's call an OpenCL node. So let's say I want to wire my ID directly inside of the OpenCL node. I can say that it's not supposed to go there. So what? It only takes this kind of input? Actually, no, you can indeed bind the ID. It's just that you have to do it manually. And I learned more about bindings and what it actually really means a lot during this process, because the idea of binding is that every parameter you use inside of your node, and that's also the values. I will probably be very imprecise, but what I understood is that the parameters you need to bind, the inputs you need to bind, and the outputs you also need to bind explicitly. And you have default values. This is why this one is okay, but this one ID that is not the most frequent use for the OpenCL node is not default, and you have to configure. And you can see here that, so this is indeed the correct field to input the code. And they've been kind enough to provide a little example of what's the very bare minimum of things you have to do to create an OpenCL node that works. And you have to declare your bindings. So those lines, they are not comments. The hashtags, not comments. They are used to create the bindings. And after that, you create @kernel, and this is the actual code you need to run in order for it to work. So what I will do now, I will come back to my Notion page where I've noted everything that Claude helped me understand and taught me about this. And I won't lie to you, it's Claude that has written the code. I just tried to input it in the correct slots and understand what I was doing in the process. So I won't be diving into the code just today because this morning when I was trying to review what I wanted to do for this live, I ended up running out of time. So I decided that doing the bindings today was good. So today bindings, but understanding the code will be for another session, the next one. And because OpenCL is different from Vex, I've seen a few things that I've been able to recognize from JavaScript, like ternary operators, things like that. But actually, I think I can see what the code does, but it's not crystal clear why everything is written the way it is. And in the code. So let's go to Notion. Yeah, so yeah, this is what I told you earlier. Pixel access. So the code provided is this, the snippet. I'm not sure what you can run over other than the layers, but likewise, this is a subject for another day. So you can see that we need to bind the ID at input 1, and we also need to bind the layer. So this part is similar to the Vex syntax. When you use this, I forgot the name of this symbol in English, but this AND symbol, it's for writing stuff generally. And you have to declare the spare parameters. So this wrangle is a wrangle to run over the tiles and select random tiles based on the ID. So for that, we need a threshold to have a cut. Over the threshold, you're selected. Under the threshold, you're not selected. And a seed to change the seed of the random selection. So those are our two spare parameters. So for bindings, in, out, spare param, and then the code, which, like I told you, this is the ternary operator. So if the distance is inferior to the threshold, then it's white, otherwise it's black. This I understand. Those are more mysterious for the moment, but let's just copy it on the inside the node. Are you Houdini? Yes, okay. So, and now we can do what we are used to do in other wrangles. Create spare parameters by pressing this little icon. And you can see that, so I will call another. So yeah, there's a gotcha. When you do this auto binding stuff, it's supposed to populate the bindings in two separate tabs. So there are two tabs for the bindings. I would call another OpenCL node, that is the default one. So this tab is for the input and output bindings, and this tab is for the per parameter bindings. And when you click on this, it's supposed to auto-populate things in here. The problem is that it's not always doing a very good job at it, and you must absolutely check if the job was indeed correct or not. And this time it looks like we have this one that is not needed, so we can remove it. And see, now it works. Now it understands, and the connection is allowed. It's not read anymore. We don't have any error message, and we don't see anything in our output. But this is because our parameters are at 0. So if I up the threshold, you can see that some of my tiles are popping in, and the seed is working as intended. And yeah, so this is it for the binding part of this select ID, select random ID, OpenCL wrangle. I don't know exactly how we are supposed to call that node, but at least now I can, and now I can use that to, I don't know, I can use that to make every, so let's, I mean, it's pretty obvious the uses that you can have for this node, but let's say I want to desaturate part of my tiles. I will use the saturation adjust node, input the results, take a look. Everybody's back. I use the mask, and now I remove saturation, and I have some nodes that are saturated and some others that are not. And yeah, this is something I wanted to learn how to do for a long time, and now I can do it. I don't have a use for it right now, but I will definitely keep that in mind for future uses. And earlier when there is some point where the calculation inverts the selection, and I suspect that this is not correct, and this is probably the snippet that is not providing a robust solution, because we shouldn't invert, but this is a subject for another time. Oh, I will understanding the code. A part of understanding the code will be understanding, will be understanding the inversion. All right. Okay, so yes, we are moving on nicely. I've been using a Mac for this whole week, and now my fingers are messed up again between the Alt and the Windows keys, etc. So excuse me for this. Okay, so last difficulty, the data window. This was a hard one for me to figure. So let's move back to this, because this is where it happened. So let's remove that and that. No, I shouldn't have removed the transform. Okay, there's only one scatter shape because, yeah, we used 7. So now the jitter scale is too low. Now we have cropping. All right. Yeah. Okay, I like this seed. So yes, data window. It will be a little more difficult to explain, but let's do it anyway. So let's go on the photo, just the photo at the moment. So what we need to, sorry, sorry for the big interruption. I've been like brain freezing. Let's go to Excalibur 1 sec. I think it will be easier. So we have two types. We have two windows. We have the display window and the data window. And apparently, those are not Copernicus. Those are not Copernicus concepts. Apparently, those are not Copernicus concepts. They are OpenEXR concepts. And the display window is what you see, the boundaries of the composition, to say so. In Photoshop or Illustrator, it would be the artboard. So this is the display window. And the data window, it's everywhere you have information. So in Adobe equivalent, it would be the layer. The layer is not bound to the artboard. And likewise, you can have things in the display window that are completely empty. And in the data window, it's the same, but yeah, this was a really bad explanation. Anyways, let's say display window is the artboard. And data window is the layer boundaries. And this explains actually pretty much the behavior that tripped me over the last time. I don't like this arrow head, so let's just use this instead. Yes. And all right. And when you use the rasterize option in the transform nodes, it's basically saying that it's basically forcing the data window to match the display window. So, see, if I don't rasterize, I'm moving my finger around, but right now I'm not seeing anything happening because just the visualization is weird, I think, but it actually makes sense because this is the default position of the pixels in the display window. And since we're not rasterizing, the transform node is only moving this display window around. And here we're visualizing. This allows us to visualize, sorry, it's hard for me to say. This allows us to visualize the movement we're giving to this display window. If we were on our blends, it makes the thing pretty easier to understand. So this visualization is more useful after the compositing operation if you are not in rasterize mode. Here, you just know that you are moving around without exactly viewing where. But if I rasterize, on the contrary, it will move the pixels inside of the display window. And once this operation is done, the pixels that are over, they're lost. They're not stored anywhere. It's rasterized. It's equivalent to cropping. See? And that's why if I move again with another transform, and I don't rasterize this time because I'm already cropped, okay? And if I rasterize, see, it's cropped. Those pixels are lost. And that's why the other time I was having those crops that I did not understand. It's because the border behavior has been triggered by the rasterize option. And this is why it was difficult for me to understand, because with the rasterization option turned on, and it's the default, you basically crop your pixels according to the canvas size of their own layer, so to speak. This is very imprecise, but I think visually you probably can understand where I'm going with that. Anyways, so this makes it much clearer now. And it also allowed me to understand something pretty important that I did not really realize before, and this is the following. So first thing, so I'm not sure I remember exactly how it works in Nuke, but I think it's related. In Nuke you always use the B. I don't remember the naming and how it's supposed to be. But I remember that there's a particular way to compose things, and you always put the B at the bottom and the A at the front, and we have something similar here. So what happens when you use a blend node with two inputs that have very different data window? No, not data window, display windows. This is the display window. And by the way, no, I will come back to that at another time. So here I have a vertical display window and here a horizontal one. And it's always with the blend node, the background layer, the background source that defines what is the display window. See, if I invert, so I can use swap background and foreground and break this rule. But if I do that by wiring, you'll see that it's a very different story. See, now the display window is the one that is brought by the picture layer. So this in itself has been very helpful for me in my Copernicus journey, and yeah, I wanted to share. So let's rewire that correctly. The other thing that I think is important to understand and that I did not understand until this moment is the following. So let's create a constant node to have a solid RVB and choose a color. Let's use this steel. And I will shape it as so I will use the resample node. Oh, I turned off my light by mistake by clicking accidentally on my stream deck. Anyways, so let's wire that here and a size ref. So I think it's just you have to find layer. And now I can say that the size I want is, let's say, 500 by 50. So we have, no, I want to do the other way around to create like a vertical rectangle. So let's move it here. Okay. I forgot, but I think we need to change it. Yes. Okay, so now we have our stick till. If I use a null, it still has, okay, so this is quite still a little unclear to me, but I have a layer that is what annoys me that is that I don't really want this space here. So let's see with the transform. Okay, so no, this is a leftover. We don't really have, so this is telling because we have this left space that is a leftover of the resample. I don't really know why it's there, but the transform nodes in Rasterize. So let's also make that RGBA because here you can see that since I don't have an alpha, this is a black solid, and maybe this shouldn't be a black solid. So we can see with the rasterize option that, and the fact we moved it on the left and that it disappeared reveals the fact that the display window is indeed the size of the size ref of the layer node. So, okay, so by changing it, I got rid of the color, which I don't want. So we know that we have a 500 by 50 stick solid that we can now blend over this whole setup. So let's keep that as the background and that as the foreground. So you would expect to have the same size, right? At least I did. But this one is unexpected too, so let's just make it over. Oh yeah, that's because I'm in alpha mode. So let's move back to RVB. And so we know for a fact that this is 4K because it's the size of the COP network. And this has been scaled to fill the whole composition. And yeah, this tripped me over a little bit. And one funny thing is that when you use the transform node, you can see that its real size is this. It's revealed by this little option. I don't know exactly. Image handles follow display flags, or image follow display flag, handles follow selected node. Okay. Yeah. Good thing to know. And yeah, we can see that. Oops. This is not what I wanted to do, but this is so small. I don't want to. Okay, so since I'm still in rasterize modes, we are cropping our thing, but that's not the point. The point is the size. So I'm sorry, I took a long time just to tell you that actually the size in Copernicus is kind of normalized. What I mean is, if you take a look at this composition, you can clearly see that the x-axis is -1, 1, and the y-axis is a function of the x-axis, and this gives us the format. So if I look at this one, yeah, okay, bad example because we have this leftover stuff of the resample. This is annoying. How could I have it? So let's just use a blend node, maybe. It will clean that up. I'm not sure it will, but why not? Now we still have this. So this breaks my point a little bit, but let's take a look at the picture rather. So here we still have x at -1, 1. Huh, I was wrong. It's not always x that is -1, 1. It's the bigger size that is 1, and the, or is it? Yeah. So it's always xy, which makes sense, but it's normalized after the biggest size. And if I do that, so let's remove that. Let's remove the rotation. This normalization makes it so that the layer will be scaled to fit the normalized space. I don't know how to put it otherwise, but it's probably, maybe it's not the most accurate description, but this is how I understand it. And this answers a lot of behavior that I found to be weird before that. Anyways, so I'm happy because I've covered a lot of the stuff that I want, actually all the stuff I wanted to cover in this live. And yeah, so I will just keep working a little bit and maybe stumble upon other stuff, and let's cross other items from this list. So I will try to cross that too, and at some point I will have to leave. So let's clean up this mess. You go away. So we can keep that somewhere. So this is just an example. This can go away. These two, this whole thing as well. I did not have a rope. Okay, weird. Okay. Allô? Ok. Bah j'arrive. Okay, so good thing that I finished because I have to leave right now, and oh, maybe I will come back with a very new topic for next time and not leftovers of this one. Thank you for watching.